Alright, so this chapter is mostly looking at graphs of quadratics. Number 1 wants me to figure out which graph is the best representation of the equation. So what I'm going to do is I'm actually going to grab my calculator, or I can choose to go on Desmos. I'll probably go on Desmos later on this video to show you what I mean by that if you are not familiar with Desmos. But on my calculator, I'm going to hit the y equals button, which on your calculator I believe is a yellow button. It's this button on the top left, right under the screen. Then I'm going to type in my equation. To do the fractions, I would do divides, because remember fractions and divides are the same thing, so I do 1 divided by 3. Then I have x. To do the exponent, there is a x squared button down here. It's like diagonal of the 7, so I press that. And then I type in the rest of the equation, minus 3. That is right under my light. So then I'm going to hit graph, which is on the top right corner. And then what I'm going to do is I'm going to compare my pictures. So if I look at this, it's right on the middle facing up. So right away I can tell this first picture is not right because it's facing up. And if I look, it's probably easier to see on yours than mine because mine's an older calculator. But it's going down 1, 2, 3 squares, so I'm looking for the one that's going down 3 squares. These two both go down 1. This one goes down 3. So that one's my right choice. Okay. On number 2, it wants me to find the ordered pair of the vertex. This one I am going to use Desmos for. So if you've never been, the website is www.desmos.com/calculator. And then it's a little bit off my screen, but I'm going to type in the equation. So I just type this in like I would type in on Canvas. So to, whoa, not what I wanted. That. So 6x plus 7. Okay. So what I'm going to do is I'm going to hide my equation editor, and then I see this. Remember, vertex is the higher low point, and it's the point in the middle. So I just put right here. It's 3, -2. So I'll go back to my paper. My ordered pair of my vertex is -3, 2. That is it. Number 3, I'm looking for my axis of symmetry. Axis of symmetry is my x value of the vertex. Go back and tell you this is the right one, just in case you don't just look at this picture. I mean, it's okay. So I'm going to go back to Desmos. And this one is like this. So I'm going to hide this, and I'm going to move my graph. I just click the screen and drag it, and then I'm going to click right here. So I just want the x value of my vertex, which is 3. So I'm going back here. I'm looking for the choice that is x equals 3. It's B. Same thing on number 4. I'm going to go back to Desmos, type in my equation. So I'm going to just put that x squared minus 4x plus 6. I'm going to, let me see if I can make this small. Oops, smaller. So click in the screen and see. So what I'm going to do here is I'm going to click the home button, and it brings me right back to the center of the graph. This one also wanted to find the vertex, so I click this. Vertex is the middle point, so it's the whole coordinate point. It's going to be 4, comma, -2, my answer. Okay. Number 5 wants the domain and range. Remember, domain is the x values, and range is the possible y values. That is important. Going back here, I'm going to look in the equation. So I'm going to parentheses x minus 2 squared minus 7. Okay? So what I do to find domain and range, for all quadratic equations, it's going to keep, if I just keep going, it's going to keep going, oops, it's going to keep going left forever, and the same thing on the right side, it's just going to keep going right slowly, but it's going to keep going right forever. I just click home to go back. So if I go back to my paper, my domain is all real numbers, and they will be for all of the quadratic equations. And my change is my possible y value. So if I go back and look at this graph, it starts down here, and then all my other y values are above this point. So my lowest y value is my y value of my vertex, so the -7. And because they keep going up, they are greater than. It can also be -7 because that's the point of the vertex, so its y is greater than or equal to -7. Okay. Moving on. This one wants me to describe the transformation of f(x) equals x squared, represented by the function g of x equals x minus 4 squared plus 5. So I'm going to do this one. I'm going to go back to Desmos, except this time I'm going to graph them both. I'm going to start with g of x. And then of x equals x squared. The second equation I typed, the blue one, is the parent function. The red one is the function. So I'm trying to see how this red one is different than the blue one. So if I look at my vertex, this one's 4, 5, and this one is 0, 0. So I can already tell it's moving 4 to the right, and then it's going 5 up. So that's pretty much how I compare these, is I look at how they're shifting. And then they are also opening at the same amount, so there's no change in the stretch or shrink. So going back, I'm looking for 4 units right, 5 units up. 4 units right, 5 units down, no? 4 units right, 5 units up. So it's my choice. Number 7 is similar. I'm comparing two graphs. I'm going to go back to Desmos. I'm going to change my first equation to match the one on the paper. So it's 4x minus 1 squared minus 3. And now I'm comparing the blue to the red again. So my blue vertex is something like that. And then this one is 1, -3. I can also see that the red one is skinnier, so that means it's got a vertical stretch. Vertical stretches are the numbers out front. So if I look over here, this 4 is going to be my vertical stretch. It has a vertical stretch of 4. And the way I can tell it's the difference between a stretch and a shrink is if I have a rubber band. Let's set this right now. So if I have a rubber band, the more I stretch it, the skinnier it gets. The more I squeeze it, the fatter it gets. So when it's getting skinnier, it's stretching. So I said it has a vertical stretch of 4. I need to look at my graph here. It's going right 1, down 3. So right 1, down 3. On number 8, I'm looking for which one has a vertex of 1, 2 and passes through the point 5, 18. These ones, they are in vertex 1, so I am looking for something that inside the parentheses has the opposite sign, please. So standard form of vertex 1 is y equals a, parentheses, x minus h squared plus k, where h comma k is my vertex. So if my vertex is 1, 2, I am looking for something that has an opposite sign in the parentheses and the same side outside. So I can already tell these two are not right. And then I just have these two choices. What I'm going to go do with these two choices, so I'm going to go back to Desmos and type them both in. So I have x minus 1 squared plus 2, 2x minus 1x squared plus 2. And then I'm going to type in a third thing here, which is the point I want it to go through, 5, 18. I'm going to go scroll until I find this point. Just on my green graph, I look over here, my green graph was the x minus 1 squared plus 2. So if I go back to my paper, it is choice B. On number 9, it's talking about a football going into the air and modeled by this function. So this one is probably easiest if I use Desmos. It wants me, what's going on in this problem is this guy is kicking the football, and it's going like that. So this is where the football starts in the air, and this is where it lands. I want to figure out how long it takes to land, so since that's on the x-axis, I'm looking for my x value. I'm going to type this on the Desmos, but instead of t's, I'm going to use x's. So let's go ahead and delete all of these. Negative 16x squared is 64 x plus 3. Let's go back home to make the graph look normal. And over here is just kidding. This one wanted the maximum height. So what I do for maximum height is I look at the high point. Height is my y value, so it's going to be 67 feet. So it goes 67 feet high before it starts and turns around and goes back down to the ground. Sorry. Okay. On number 10, it wants to find the two true statements, so I'm going to go ahead and graph this on Desmos. What am I doing? X plus 4 squared minus 1. Okay. This one I definitely want to go back. So I'm looking at the paper while you're looking at the graph, so I'll read the choices I have. I have the minimum value of f of x is negative 1. So what that means is if I'm looking at this graph, the y value is negative 1. So if I look at this, my minimum value is negative 1. So I'm going to go ahead and pick this one. It wants me to select 2 that apply, so there's one more. That is true. Let's go back to this one. The next thing says it has a 0 at x equals negative 4. So zeros are where they cross the x-axis. Neither one of those are negative 4. So that's not right. It says that it has a maximum at x equals 4. X equals 4 isn't even in this picture, so that's not right. It says it has a minimum at x equals negative 1. X equals negative 1 is right here. Also not right, because that's like the middle of the graph. Next one is the maximum value of f of x is 15. I cannot have a minimum and a maximum value on the same graph, so this is also not true. And the last one says f of x has a 0 at x equals negative 3. X equals negative 3, there is a 0 here where it crosses the x-axis. So that last choice is my last answer. Okay. Moving on. Number 11 gives me a graph. It wants me to figure out the maximum point of this graph. So I'm looking right here for the coordinate point. It's going right 1, up 4, so my coordinate point is 1, 4. If I take a look at number 12, it wants me to find the vertex of a function and decide if it's a maximum or a minimum. So I'm going to go ahead and type this equation in. Okay, so if I look at this, it's a mountain. Mountains are maximums, and it's at 0, positive 2. So I'm looking for maximum with 0, 2. Number 13 is looking for a quadratic function whose roots are negative 5 and 1. It means crosses the x-axis. So I'm looking for one that crosses at negative 5 and positive 1. This crosses at negative 1, positive 5. This crosses at 1 and 5. This one's not right at all because it's going the wrong way. This one is negative 5 and positive 1. So it's the last one. Okay. Number 14 wants me to pick the best representation of this one. I'm going to go ahead and graph it on my calculator so I can see all of them at the same time. I have 3x squared minus 3x. Go ahead and graph it. And we're looking for the ones that are. This one is not quite in the center, so I know this one and this one are not right. And then I'm going to look, it goes down 1. This one goes down like 2.5. So my correct answer here is this one right there. Moving on. This one is asking me to find 2 of the graphs that share the form f of x equals x minus c squared plus 3 for several numbers c. So since this has a letter instead of a number right here for c, I cannot actually graph this on my calculator or Desmos. What I do want to do, however, is I notice at the end, just going back to that vertex form I told you, so the x minus h squared plus, oops, that should be okay, not a thing. So what this is telling me is it's 3 up. So if I draw a line at 3 on all of these, I'm looking for the 2 that have their vertex at 3. So if I notice these 2 draw through, this one just totally doesn't touch, but these ones touch perfectly at the vertex. The vertex, remember, is this point right here. Okay. Number 16 wants me to figure out which one of these equations will give me the graph that is given. If I look right here, I see it's crossing at -3, and right here it's crossing at +3. So I'm looking for one that has a positive and -3. That's not A. It's not C. I never really worked with something that looked like this up until this point, so it's not this one. It's D. Number 17, it's going back to factoring. It wants me to find 2 functions equivalent to this, so I'm looking for what multiplies to 8 and adds to 6. So that would be x plus 2 and x plus 4. If I'm really stuck on this question and I cannot remember how to graph, what I would want to do is I'd want to go on Desmos, graph this one, and then graph these 4 choices and see which of them match the graph. On number 18, it wants me to find the zeros of this graph. I am going to go back to Desmos and graph this one. This is a possible password. Okay, so when I go ahead and graph it, zeros are where it crosses the x-axis. I have -1 and +1. So that is choice 1. Same thing on number 19. Wants me to find zeros. So we'll go back to Desmos. So I create this equation. So notice I only see one right now, 0. What I gotta do is I gotta move this over so I can see the second one. And the second one is 13. So x equals 0. X equals 13, anything. Number 20 wants me to find all the zeros of this other function. So we'll go back to Desmos and graph this one. I have x squared minus 14x plus 49. I look, I see it only bounces off, it touches once, so I only have 1 0. 7. So it's positive 7. This one has a wrong answer on the answer key. So I'm just going to write x equals 7. Number 21, it wants me to figure out which of these statements is true about this graph. I'm going to go ahead and type this into Desmos and leave the graph on the screen while I read to you what the choices are. It says the graph passes through the x-axis at x equals 3. The graph touches the x-axis at x equals -3. The graph passes through the x-axis at x equals -3, and the graph touches the x-axis at x equals 3. So, oops, right here, if I look, it's going to touch and bounce right back out. So this one is not passing through, and it's a positive 3. So my choice here is D. Okay. On number 22, roots. It's just another way of saying crosses the x-axis. There are lots of words for that. There is roots, solutions, zeros, x-intercepts, all those things mean the same thing. So if I look at this graph, it's not crossing the x-axis. No real roots exist. On number 23, I can graph this, or I can take these pieces and set them equal to 0. So I have x minus 1 equals 0, x plus 3 equals 0. Once I've taken them and set them equal to 0, I want to go ahead and solve them. So I add 1 to both sides, I get x equals 1. Just going to subtract 3 on both sides, I get x equals -3. So I'm looking for the one that's crossing at +1 and -3. positive 1, negative 3. This one is it. Now I'll have to look at the other graphs. Okay. Moving on. We're almost done. 2 more questions. This one gives me a graph, and it wants me to decide everything that's true. It gives me a second one it wants me to graph. So to see the both of them at the same time, I'm going to go ahead and graph this on my calculator. I'm going to graph this one. So I have, you can't see what I'm doing. Negative. When I have the negative out front, I want to make sure I pick the white negative on the bottom of my calculator. Calculator's not very smart. Doesn't know the difference between negative and subtract. So I'm going to go ahead and type in the negative out front. And I have x squared minus 4x minus 3. So the first negative is the white button. The other ones should be then I hit graph. So this is what my graph looks like. It says the y-intercepts of f of x and g of x are opposite. So if I look up here, my y-intercept is 3. If I look at my calculator, I don't spin it around. It's going down 1, 2, 3. So it's negative 3. This is true. They are opposite values. One's positive and one's negative. The next thing it says it has an x-intercept at negative 3. So this one, let me determine where my intercepts are. There's 1, 0, and negative 3, 0. I look at this graph, it's crossing at negative 1, negative 3. So if I go back over here, negative 3 is the correct choice. Why does this paper keep spinning? This one wants me to match my correct types. There are 2 ways I can do this. So I can go by shape. If I graph all 4 of these, quadratic are U-shaped, exponential are curvy-shaped, and linear are straight. Another way I can tell is quadratic has exponent of 2. Exponential has an exponent of x. And linear has no exponent. I'm going to go ahead and match them. On quadratic, I'm looking for an exponent of 2. That's choice number 4. Exponential is an exponent of x. That's choice number 3. So I'm going to write this over here just in case my lines are a little confusing. And linear is no exponent, which is 2. So it's okay that I don't use 1. I just have 1.